Hello, good morning. Good morning and happy May the 4th, Star Wars Day. Okay. So just to explain my plan a little bit in case the giant paragraph was confusing. So, remember that I only planned to teach you up until the ACT happened, and since it has not happened, and we're like several months after that, I had everything planned up until then. And so anyway, so I ran out of my plan. And considering it's the end of the year, I just feel like why don't we just do more practice and then you guys can focus on what other things you need to do. Um, so anyway, so I'm not gonna have you take notes for the rest of the year. We're gonna only I mean, school ends, well, you don't get new material from any of your teachers after the 15th. So we only have 2 more weeks, which is wild. We're almost done. Um, so we're going to spend like most of those 2 weeks just doing pieces of the ACT. Um, I just pulled questions from different parts of the ACT, so we're going to still do like there's still that progression from the easy questions and the hard questions. So there's some pulled from other different places. Um, so you have the same assignment that I'm doing today on Math Space. So um, it would make a lot of sense for you guys to work on this with me. And I'm just gonna go through each question and talk about the way that I would approach it. I feel like watching somebody else do, or at least hearing the way that other people's brain works when they do math, is helpful. So I am going to show you what I would do, and I'm also going to try to explain my thinking and help you to understand these questions too. Most of them, if not all, are stuff we've already gone over this year, at least once. My dog needs attention. Um, so they shouldn't be brand new, but they are from the ACT, so we're not, you know, you never know. Yeah, so that's the plan. I'm just gonna go through your homework with you, and so hopefully once I've quit streaming, you will also be done with your homework, so you won't have homework really for my class. So this counts both as participation and homework, kind of. So I'm gonna just start with number one here. This is called R1. I just picked R because it's like review. I don't really know. Who knows? I don't know anything anymore. Hello, good morning. Um, okay, yeah. So number one says Quentin, hmm, deposits $9,282 in a bank and leaves it for 1 year. If the interest rate is 8% per year, find the total amount to the nearest cent in his bank account at the end of the year. Uh, so we have a starting amount of 92.82. And every year it gains 8%. So you might remember that the way that we find percentages of stuff is that we figure out what the percentage is as a decimal. So 8% is the same thing as 0.08 in a decimal form. And we need to figure out what 8% of 92.82 is so that we can add that onto his total bank account. Yeah, log into MathSpace. That would be good. Yeah, so we're going to multiply 0.08 because that's trying to find a percentage is just figuring out what the percent is as a decimal and then multiplying it to your amount. So I'm going to multiply it by 92.82, which equals 92.82 times 0.08 is 742.56. And so it's not like his bank account is going to get less, right? It's not going to go down to $700. That would be really bad. we are adding this 742 onto what he had because it's earning that 8% interest. So we just need to add those two numbers together, 9282 plus the 742.56, which ends up equaling 1024.56, I think. 10,000, I mean. Which is B. So yours might have different numbers. Same process though. If you want to be tricky, there's another way that you can figure this out without having to do it separately and then adding them together. If you multiply instead of I'll do this in a different color. If you instead of multiplying by 0.08, you multiply by 1.08. That one indicates that you're keeping what you have and then you're adding that little 0.08 onto it. So if you actually do this in a calculator, this 9282 times 1.08, it ends up equaling your answer already. So if you can remember that, that's cool. Just remember, the way that I remember that is that if you multiply anything by 1, it just stays the same. So we're multiplying by 1 and then a 0.08 to like add that little bit in the end. So we're keeping what we have and adding 0.08 on it. Number 2. John has 5 math classes, 6 history classes, and 4 economics classes. Let me write that down. He has 5 math classes, 6 history classes, and 4 economics classes. Oh, and 3 accounting. And 3 accounting classes to choose from this semester at university. If he has to select one of each class to enroll in, how many different ways can he select his classes? So you might remember, I think we did this as a warm-up once where we did like the ice cream menu and you are trying to figure out how many different options there is. All you have to do is actually multiply how many choices you have in each category together. It's called the counting principle. That sounds broader than it actually is. I don't know why they call it that, but it's called the fundamental counting principle. And so you just actually have to multiply the number of options you have in each category together, and that will give you the total number of like different combinations you can have. Which in this case equals 5 times 6 times 4 times 3, 360. We have to work on that speed, right? That's the hardest part of the ACT is only having 60 minutes. So you could figure that out if you just wrote all the options out, but it would also be really painful and take a long time. So remember that counting principle. If you have a bunch of different things you're choosing from, like ice cream menu or something, you can multiply how many options you have in each category and it'll give you the total number of combinations. Okay, Victoria and Sarah scored goals in their netball game in the ratio of 4 to 5. I don't know what netball is. I just realized that. Okay, so they scored it in a ratio of 4 to 5. If they scored a total of 27 goals, how many goals did Victoria score? So here's what we're going to do. We know that the ratios again are like fractions. So if the bigger numbers can reduce just like fractions into smaller ratios. And remember that when you reduce, did my pen just stop working? No. When you reduce fractions, it's basically like you're dividing both numbers by a certain thing. So what I'm going to do, this is how I initially thought to do this problem, and so I'm going to do it this way because I'm going with my first instinct. That's a pretty good idea when you're doing tests. I'm just going to multiply 4 and 5 by certain numbers, like by different numbers to figure out like, because we just want them to add to 27. That's all that we need. And so it's really hard to figure that out unless you just do sort of an experiment. So what I'm going to do is multiply my ratio by 2 first. So by 2, that gives you 8 to 10. And 8 plus 10 is only 18 goals. So that's not enough. So I'm going to multiply by 3. That gives me 4 times 3 is 12. 5 times 3 is 15. And 12 plus 15, look at that. 12 plus 15 is 27. It's 27 goals. So that means that while they scored a ratio of 4 to 5, one of them scored 12 and the other one scored 15. They just reduced that into the ratio of 4 to 5 by dividing each number by 3. And we just worked backwards from that. I just multiplied by 2 and then 3. I would have kept going if it was a bigger number and I had to keep getting more. But that means this is the ratio, 12 to 15. And something that is sometimes like, I don't know, it's hard, is that like ratios are always in order. So it says Victoria and Sarah scored goals in their netball game in the ratio of 4 to 5, which means that Victoria is the first number and Sarah is the second one. It's Victoria to Sarah. So if you're confused about that on the test, look for clues. If they've already listed something in an order, it's probably because the ratio is in that order. So Victoria must have scored the 12 points and Sarah must have scored 15. And it's asking about Victoria. So we're looking for 12 in this situation. And my options are on the other page. So this one. That's what we're looking for. Okay. I'm going to kind of do this similar process on this next question. A stack of playing cards contains 2 clubs, 4 diamonds, 2 hearts, and 8 spades. How many additional spades must be added to the stack so that the probability of randomly drawing a spade is 3 out of 5? So the only thing we care about is spades in this situation, spades and how many other cards there are in the deck, because it's only asking about the probability of drawing a spade. So I'm going to make a fraction where we have spades over everything else, or out of the whole deck, I'll just say that. So the spades, we have 8 spades, and the whole deck includes the spades. So you have 8 spades plus 2 is 10, 2 hearts, plus 4 is 14, plus 6 is 16 for the clubs. So we have 16 total cards in our deck. So right now it's an 8 out of 16 chance that you'll draw a spade, which is a 1/2, which is fine, but we want it to be 3/5. And so I don't really know I don't know if there's like a specific process they're looking for in that, but immediately in my brain I was like, okay, let's just add 1 spade at a time and see how long it takes us to get to 3 out of 5, 3/5, or a fraction that can reduce to 3/5. So I'm just going to add a single spade. The clouds just covered the sun. Hang on. The light. Okay, we're adding a single spade, which means that the top number will go up 1 because now I have 9 spades, but it also means that the whole deck will also go up 1 because I'm inserting another spade. So it's now 9 out of 17. I should not put in equals because those are not equal. So what I just did there was add a spade. And I'm going to do that a bunch of times. Because I need a fraction that I know will reduce to 3/5, and 9/17 does not reduce at all, much less to 3/5. So now I'm going to add another spade. That'll give me 10 spades out of 18 cards. That reduces a little bit. You can take out a 2, and that will be 5 out of 9. That's not what we want, though. It won't reduce any further, so I'm going to add another spade. Which will give me 11 out of 19, another terrible fraction that doesn't reduce at all, so that's not it. I'm going to add one more. And now we have the fraction 12 out of 20, 12 spades out of 20 total cards. 12 over 20 reduces, if you like take out a 2 first, I guess, give you 6 out of 10. If you take out another 2, it'll give you 3 out of 5. Which means that we have now found how many spades we would have to add. We added 1 for each of these arrows. I added 1, 2, 3, 4 more spades into the stack in order for it to be 12 out of 20. So that means this is the answer. We added 4 spades. So each of those fractions is just me adding a single spade into the deck. And I upped the number of spades, which is the top part of the fraction, and then I upped the total, if they would reduce to 3/5, because that's the probability that I wanted. Yeah, so that's 4 spades we added. Number 5 is on the next page, apparently. Okay, a statistician organized a set of data into the frequency table shown. What is the average score to the nearest 1 decimal place? So a frequency table, if you remember, we did do this. A frequency table lists, so like if you have a list of numbers where you have a bunch of repeating of the same number, you can list them in frequency tables instead. So what this means is that you have somebody scored a 1, actually 5 people scored a 1. So there's 5 1s in this list, and then there's 15 2s, and then there's 13 3s. So you have this giant list that's just represented in this frequency table, because it's easier to list them that way instead of listing 1 1 1 1 1 3 3 3 3 3. You know what I mean? So the way that we find an average. So okay, so sorry, I didn't see your question until just now. Um, Reducing fractions comes from being able to, like, there's something that goes into both numbers. So for 12 and 20, I noticed that there's a 2 that can go into both of those. A bad example is 11 out of 19. Neither of those numbers, they don't have anything in common. They don't even have a 2 in common, because both of them are odd. So that one doesn't reduce because we can't take out anything from both of those numbers. So you just have to leave it as 11 over 19. 12 over 20 is much better because it has a 2 in common, and once you take that out, it also has another 2, which means that you could have taken a 4 out of both numbers, which reduces it to 3/5. Good question. So the way that you find an average from a frequency table is you are, like, remember your normal process for finding an average is adding all the numbers up and then dividing by the number of numbers, right? So it's like the sum over the number of numbers. That's the average. So in a frequency table, to find the sum of all of these, what you can do is just take the score that you're trying to add and then multiply it by how many there are, because that's the way that multiplication works. You're just duplicating that number a bunch of times. So I'm going to multiply my score 1 by 5, because that's how many 1s there are in my data set. And I'm going to keep going. I'm multiplying my score of 2 by 15, because there's 15 2s. And then I'll multiply my score of 3 by 13, and then 4 by 20. I'm running out of room. And then 5 times 9. So that's how I get my sum. And I will put that in the calculator in a second. But we also need the number of numbers, which, if you think about it, is pretty easy to find because we have how many numbers there are of each score, how many duplicates there are of each score. So we can just add all of these numbers together, all of the frequencies together, and that will give us how many total numbers there are in our set. So our number of numbers comes from adding all of our frequencies. So I'm going to grab my calculator. I'm going to find the sum. 2 times 15, and you can really just put all of this in at once. Just make sure you're putting addition in between them. 4 times 20 plus 5 times 9. I got 199. So that's right. I think so. And then I'm going to add all of my frequencies together. And that gives me 62. So my average will be, we just put 199 over 62. Hopefully I did it right and it's there. 3.2 is what I got. Which means the average, that's the average, 3.2. Maybe I'll highlight some stuff. So here's where we're finding our sum. And here's our number of numbers thing that goes on the bottom. And then you divide. Okay. Okay, I know that you get scared when you see this equation, but I promise actually it's just plugging stuff in. It says given that the perimeter of an ellipse is pi over 2 times the square root of 2 times h squared plus w squared, where h is the height and w is the width of the ellipse, what is the perimeter of the ellipse below? So literally all it's asking us to do is plug stuff in, and then you'll see actually on your answers, the answers are not decimals, they're sort of closer to just stuff plugged in. So I'm writing out the equation, 2 times h squared, the height. Hang on. I'm going to just leave myself space to plug in both of those things. So the height doesn't really matter which, I don't think. There you go. I plugged them in. I plugged in h and w in my equation. I'm going to take a peek at the answers. Square root of... Okay. It looks like it wants us to find out what is underneath the square root. So I'm going to plug in 36 squared plus 15 squared. Which I got is 1521, 1521. We still have pi over 2. And I'm gonna see if I can square root 1521 because from the answers, it looks like we just have a square root of 2 left over. So I'm using my answers as kind of a hint to where to go with this problem. So I'm assuming that since there's a square root in the answer, square root 2, I can't actually square root that. I'm assuming that just stays. But that also means that I will be able to square root this 1521. And it turns out I just plugged it in. It does work. You can square root 1521. So I'm sort of, in my brain, I'm separating these out into square root of 2 and square root of 1521. Which you can do because they're multiplied together. You can't do it if it's added, but they're multiplied, so you can split them up. And the square root of 1521 is 39. I just checked. So now we have 39 times the square root of 2 times pi over 2. That might already match something, but I can't see the answers right now. I'm just going to rearrange it a little bit. 39 doesn't divide by 2, so there it is. Look at that. 39 over 2 pi root 2. Kind of have to be flexible with these kind of things because you can rewrite that same equation like 10 different ways. And so you have to look for equivalence, not exactness, right? So like 39 over 2 times pi times root 2 is not exactly what I have here. I started with this, the pi over 2, and then the square root of 2, and then 39. So you can rearrange this to look like the answers, but again, just be flexible because you never know how they're going to write it. Just look for something that's equal, not exactly the same. Okay, number 7. This is our favorite one. I think I assigned this question to you, like, I can't remember when we did fractions or something like that. This is the one about the container being a certain amount full and you have to add an amount, and then it's weird. Again, remember I said this assignment goes from easier questions to harder questions, just like the ACT does. I just picked 10 from beginning, middle, end. So this is one of the more difficult. This is at the end of the ACT. So it says a container is, here's my container. It's gonna be like a beaker because that's the only way to do stuff. Fractions. Here's my beaker. And it says at the beginning it is 1/12 full of water. So this is a 1/12 of the container is full already, right? And then we add, after 60 cups of water are added, the container is 5/6 full. So 5/6, the first thing I did was change this into twelfths because I don't want to have to deal with two different denominators in my fractions. Like I want to be able to compare them. So I just multiplied those both numbers by 2 because 10 out of 12 is the same thing as 5 out of 6 when you reduce them. And then if I have 10 twelfths, it compares much better with 1/12. It's like the same units, kind of. We have 1/12 and 10 twelfths to compare. So after we put 60 cups of water in there, it is 10 twelfths full. And we know that this is 60 cups of water. That just this piece, hang on. If it makes you feel better, I was just looking at this problem before I streamed today and I did it wrong the first time. So um, if you're like, this question is really hard, you're right, it's hard. I keep doing it wrong. So that's okay though. There we go. So just that purple part is 60 cups of water. Here's the thing we need to figure out. First of all, how much of the container is just the purple part? Because the 10 twelfths and the 1/12 are total, right? So 10 twelfths includes the 1/12. So we want to take out the 1/12 and just figure out what those 60 cups were, which 10 twelfths take away 1/12 is 9 twelfths. Yeah, 9 twelfths. So 60 cups is 9 twelfths of the container. And our job here in the end is to figure out how much the container holds total. So what I'm going to do, I need to figure out how much this little piece holds and these little pieces hold, to figure out the total capacity of the container, because I already have 60 cups, so I need to figure out the other two. So I'm going to use that 60 cups thing and figure out what 1/12 that first little piece is. So if 9 twelfths, hang on, let me get my purple marker. So if 9 twelfths is 60 cups, what we can do is divide 60 into 9 pieces so we can figure out what 1/12 is, right? Because if 9 twelfths is 60 cups, what is 1/12? You would divide the 60 by 9. So dividing by 60 by 9 does not give you a nice number, which makes this problem even more annoying. You actually get 6 2/3 cups, not 2/2, 2/3, sorry. You get 6 2/3, which is like a mixed number, yikes. So 1/12 is 6 2/3, so that means that this little piece is 6 2/3 cups. the little blue piece. And then up here, believe it or not, because it's 10/12 at that line right there, you actually have two more 1/12. So you have two more 6 2/3 for both of those little pieces. 6 2/3, 6 2/3. Cups, right? So our last step here is to add all of those things together. So the worst part is adding 6 2/3 together 3 times. So I'm going to do that first. I'm just going to figure out what 2/3 plus 2/3 plus 2/3 is, so I can add those nicely. And if you can actually do that 2/3 by 3, because I'm adding 3 of them together, and look what happens when you multiply 2/3 by 3, you just get 2 cups. 2/3 plus 2/3 plus 2/3 is just 2 cups, 2 normal cups. Which, hallelujah, because I didn't want to have to deal with any more fractions. So now we just added those 2/3 3 times. I'm just trying to add these things together, which means that we have 6 plus 6 plus 6 plus 2 plus 60. As the total number of the total capacity of the container. Yeah. So 6 plus 6 plus 6 is 18, plus 2 is 20, so we have 20 plus 60, which ends up being 80 cups. Not 18, 80 cups. So I know that question is a zinger. So hopefully you're able to figure it out with whatever numbers you have. If you need to rewatch what I did, you should be able to just follow that pattern. Yeah, hopefully. Again, let me know if you have questions. I don't think that unless you request it, I don't think I will do a study session today just because I'm like doing your homework with you. But if you would like to sit and chat and do your homework with me, I will do a study session. You just have to tell me. So, okay, last 3 questions. Is that number 7? Yeah, it was. Now we have some trig. Okay, so even me looking at this, I was like, yikes, what the heck is happening? But then I realized it's trig, and then I'm like, okay, this is fine. So what I'm actually going to do first is I'm going to forget the cosine part out front, and I'm just going to figure out what tangent inverse of b over a is. So you might remember, hopefully you remember your trig ratios. Tangent, SOHCAHTOA, tangent is equal to opposite over adjacent. So tangent inverse of b over a is doing the opposite. It's finding an angle from opposite over adjacent. So if b is the opposite and a is adjacent, that means opposite, adjacent. It means it's this angle that this expression is finding. It's finding that orange angle. And because I don't have any numbers, I can't actually find that angle. But now I know what angle it's talking about. It's talking about that orange angle. And I figured that out by figuring out which angle is opposite of B and adjacent to A. Because I know tangent is opposite over adjacent. So all we have left now is to find cosine of that angle. Because that whole inside expression is just finding an angle. And so now I'm just finding cosine of that angle. And cosine is adjacent over hypotenuse. So we need to find the adjacent to that angle, which is still A. Adjacent is this side. And then hypotenuse to that angle, well, the hypotenuse in general is this nice Pythagorean theorem looking thing. So the answer or the denominator of my fraction is going to be this whole thing, square root of a squared plus b squared. And that's my answer. So tangent inverse of b over a found an angle. And I just figured out which angle that is because I don't know what number it is, and that's okay because that's not my end goal here. I just figured out what angle it's talking about. And then I did cosine of that angle to find out what the answer is. Because this whole inside portion is just finding an angle. So that's a fun one. Here's this one. That's the answer. A over a squared plus b squared. Adjacent over hypotenuse. Number 9. Which of the following expresses the number of meters a contestant must travel in a 4-lap race where the course is a circle of radius r meters? There's banging outside. I never know what it is. Okay. So first of all, the course is a circle, and it has a radius of r. We don't actually know what the radius is. I find that the closer you get to the end of the ACT, the less numbers there are. It's just like a bunch of letters, which is what they're trying to do is see how much you can recognize and compute things with just representations of numbers instead of numbers, because sometimes numbers are a bit of like, if this sounds weird to say in math, but numbers can be kind of a crutch. Like we can often use different ways to get to an answer with numbers, kind of like up above, like this trig problem. If there were numbers in there, we could have just plugged that all into a calculator. You know what I mean? But without numbers, we can't do any of that. We have to actually use like the theories that we use in math. Theorems, I guess, is a better word. So anyway, so the closer you get to the end of the ACT, the more letters they use, and that's because they want you to they want to know how much you can remember about the theorems and the I don't really know what words. I don't know words anymore. I don't talk to anybody, so I lose my words. It's okay. You know what I mean. It gets more theoretical instead of like physical, not physical. Anyway, so we have a radius of just r, and this is our lap, our race, and they're saying that you have to go around 4 times for this race. So whatever we're doing, they have to go around the race 4 times. And running around the edge of a circle is a circumference. We have to use the circumference formula for how far it is around that circle, which is pi times the diameter, or 2 times the radius. So pi times 2 times the radius. That's the circumference. So we're going to take that piece and multiply it by 4 because we go around the track 4 times. And then if we multiply all the numbers together, which we only have 4 and 2 that can multiply together, which gives us 8 times pi times the radius. There it is. So basically we have 2 times pi times the radius and then multiplied by 4, which makes it 8 times the pi times the radius. Okay, last question. What is the median of the following set of scores? This one, I don't know why it's at the very end of the ACT because it feels like the easiest question, but that's okay. Remember that median is the middle, right? Hopefully, I'm remembering correctly. 10, 11. So what you have to do is put them in order first, or else it's not going to be helpful. So I got 10, 11, and 16. Now I have 20, 25, and 29. So that one is the median. Yeah, because mean is like the average, median is the middle, mode is the most common. So hopefully 20 is one of our answers. Yep, look at that. There's the median. So I think the trickiest part of that is, oh, did I miss a number? Nice. I lied. I take it all back. 26 and 29. I missed 26. 2, 3, 4, 5, 6, 7. Oh, it's still 20. I was just circling. That was weird. Okay, yeah. It's still the answer is 20. Yep. Okay. That's all. So here's the deal. If you have questions, if you're still struggling on your homework, with the different numbers or whatever, uh, just use Google Hangouts or your email and send me a message because I'd be happy to help you. Um, yeah, that's pretty much all. So let me know, and I hope you're all doing well. I really hate doing school online, as I am sure you can sympathize with. Um, so anyway, I'm excited for, I don't know, the possibility that this will not happen next year. So that's all. Have a good Monday, guys. Maybe watch some Star Wars because Star Wars is good. And let me know if you have questions. Bye, guys.